10 power set. Let's take the definition of power set. Let A be any set, then the power set of A denoted by P of A or 2 of A is defined as P of A is equal to 2 of A is equal to set of all subset of X, set of all X such that X is a subset of A. This is read as the collection of all the subset of A. Here the collection of all the subset of A is a set, is a well defined, so it's a set. Here the collection of all the subsets of A is well defined, therefore it is a set. Therefore P of A is a set. So what is power set of A? Power set of A is the collection of all the subsets of A. The collection of all the subset of A. And this collection, since this collection is well defined, we can say this power set of A is a set. Now let's take some observation. First, this set A itself is an element of the power set of A for all set A. That is, every set A is a element of their power set. That is, every set A is the element of its power set. Second, empty set is also the element of the power set of A. Empty set is also the member of power set of A, and is also true for all the set. From the first two observation, we can say that from the first two observation 1 and observation 2, we can say that power set of A can never be empty. Because why? Because empty set is always the element of power set of A. Now let's take some examples. If A is the power set of the empty set, then this is equal to the singleton set of empty set, and B is power set of the power set of the empty set, which is further equal to the empty set and singleton set of empty set, which is equal to power set of A, and C is equal to empty set, singleton empty set, and a set of empty set and singleton empty set. This is further equal to power set of B. Fourth, if A is a non-empty set, it's a non-empty set, then we say that power set of A contains at least two distinct elements. Those two distinct elements are phi and the set itself. Those two distinct elements are the empty set phi and the set itself, and set A itself. A note: an empty set doesn't have any element, but it has a subset. Doesn't have any element but has subset. And that subset is itself, and this subset is itself. It itself is a subset, and that subset is also a improper subset, because every set is an improper subset of itself. Therefore this empty set is also an improper subset of itself. Empty set doesn't have proper subset. This also we can take it as a note. Empty set has a subset, and that subset is improper subset, that is itself, and it doesn't have proper subset. 11th, Cartesian product. Let's take the definition. Let A and B are non-empty sets. Are non-empty sets. Then we define the Cartesian product of A and B as. Then we define the Cartesian product of A and B. The Cartesian product of A and B as A cross B is equal to ordered pair of AB such that A belongs to first set A and B belongs to small b belongs to capital B. Let's take the definition again. Let A and B are two non-empty sets. Then we define the Cartesian product of A and B as A cross B, which is equal to set of all the ordered pair. This is called ordered pair. It's called ordered pair. Set of all ordered pairs such that the first element A belongs to set A and the second element B, that is lowercase b, belongs to capital B, set B. A note: here the ordered pair AB is an element of set A cross B, of the set of the Cartesian product of set A cross B, of the set A cross B, called as ordered pair. Ordered pair. By ordered pair we mean that ordered pair means AB is equal to BA implied by A is equal to B. That is, we can't change the order of the elements, the order of the elements A and B in AB, in the tuple AB, except when they are equal. Except when they are equal. Twelfth, let's discuss some operation on the sets. 4 important operation on set. First, A union B. A union B is defined as set of all x such that x element of A or x element of B. Second, A intersection B is defined as set of all x such that x element of A and x element of B. In union we write OR, and in the intersection we write it as AND. Third, difference between the set AB is defined as A minus B as set of all x such that x element of A and x not the element of B. Fourth, asymmetric B. This is called the symmetric difference between A and B, defined as A union B subtract A intersection B, or is also equal to difference between the set AB union difference between the set B minus A, between the set B and A. This symbol is called del symbol. This is called as symmetric difference between the set A and B is defined as A union B subtract A intersection B, or A minus B union B minus A. Point. the concepts of subset, power set, Cartesian product, union, intersection, symmetric difference, etc. are merely tools we need to visualize. We need to visualize new set so that we have contents to study further. We need to visualize new sets. These are merely tools we need to visualize new sets and studying some contents in further. Fourteenth, some two important sets. Some two important sets. Set of natural numbers as 1, 2, 3, 4. These are set of natural numbers or and not as 0, 1, 2, 3 and 4. Second, Sn, which is called as initial segment of natural number. This is segment of natural number. This set is called segment of natural number, defined as 1, 2, 3 up till n. These two sets we need as a tool to study the countability further in real analysis. These two are two important steps we required in study real analysis. Let's discuss a new topic, function. Functions. Let's define what is function. Let A and B are two non-empty sets. If by a rule every element, if by rule or relation we can say, if by rule or relation every element of the set A is assigned to some unique element, of B, then that rule or relation defines a function from A to B, and we denote it by a function defines from A to B. Now let's take some observation and notations. Observation and notations. First, a set A is called domain, B is called codomain, and B is called codomain of this function f, and the elements in B and the elements in B which are assigned with the elements of A form a subset of B, and the elements in B which are assigned with the elements of A forms a subset of B, called as range and denoted by f of A, called as range of the function. So range of the function f, and denoted by f of A, and denoted by f of A. Second point, if an element x belong to set A is assigned to y element of B, we say or we write as y is a function of x and y is the image of x under f, under the function f, and x is called as pre-image of y, pre-image of y under the function f, Let's take some explanation. If I define a set A as 1, 2, 3 and 4, and set B, a second set B as A, B, C and D, and I define a function from A to B, first I map 1 to small a and 2 to B and 3 to B itself again and 4 to C. Here the domain of the function f df is the whole set A, and the codomain of f is the whole set B. This whole set B is the codomain of the function f, and the range of the function f denoted as f of A is the set of all elements of B which are assigned to the elements of A. The small a and small b and small c are the elements of B which are assigned to the elements of A. That means this A, B, C has the pre-images in A, and this set of all elements of B which are assigned to the elements of A is called the range of this function f. That is A, B and C. Set A and B and C are the range of the function f. Types of functions. First, one-one function, also known as injective function. Let's take the definition. If the function f defined from set A to set B and FA is equal to FB implies A is equal to B, then we say this function is 1 1. Then we say this function f is 1 1. Second, surjective function or onto function. Onto function, also known as surjective function. If I define a function from A to B such that f of A is equal to the range of the function f, that is a subset of the second set B, and the range of the function f is equal to B, then we say f is onto. Then we say f is onto. Third, bijective function. Bijective function, also known as 1 1 onto, 1 1 and onto, or 1 1 correspondence. Bijective function, also known as 1 1 onto function or 1 1 correspondence. Let's define. If I define a function from set A to set B, and if this function f is both 1 1 and onto, then we say f is bijective.